Hello and welcome to the next video in our complex numbers series of our maths module. We're going to be looking at how to represent complex numbers in polar form after we've just had a look at our Argon diagram once more. So we're just going to recall a few things, which is first, we represent the magnitude, also called modulus, of our complex number using the modulus symbol, and we say this is equal to r. You'll see this given in both uppercase and lowercase form. And also we worked out that depending on where our complex number lies in the plane, we can calculate theta a number of different ways. You see the last video to calculate that. And so we know we can represent our complex number in terms of r and theta. So how do we write this down? So we know normally our complex number is given in terms of a plus ib. So we're going to use our complex number z1 as our example. So for z1, we can say that the magnitude of z1, or r, is then going to be equal to 3 squared plus 2 squared, all square rooted. So 3 squared is 9, 2 squared is 4, that's 13. So r is root 13. If we're to calculate theta from this, we can use the inverse of tan, the imaginary component of it 2, over the real component 3, and that gives us an angle for theta1 is equal to 33.7 degrees to 1 decimal place. But how would we write this down? How would we show this in the polar form? So we have to look at, if we're going to represent the values a and b using r and theta. So we take our number z and a. So a is our real component which lies across the x-axis of the Argon diagram. Now draw your attention to our SOHCAHTOA as we have from our trigonometry series. We say if we want to find the length of this side, coming from this angle, this is our adjacent side, using our hypotenuse, we are going to use the cosine of the angle by the hypotenuse. So we can now say that the real component is equal to r cos theta. We add to this plus I by the imaginary component, which again, if we draw our attention to SOHCAHTOA at the top, we can see that we can use sine by the hypotenuse to find the opposite side, which is just here. So we can use I, r sine theta. So this is a way of representing for us z in terms of r and theta, which is how we represent an imaginary number in polar form. But we can now go a step further, and what we can do, there's a notation for this, which is where first we factor out the r. So we have r cosine theta plus I sine theta. And then all of this is replaced by this symbol here. It looks like a less than sign, except instead of on a less than sign, I'll just show you up here, a less than sign, if you notice, is sort of an even split, whereas this angle is more like that. And then following the symbol, we have our theta here. And of course, as we have z and r, we can just put z equals r. There. So if we're now going to represent our z1, we can say that z1 is equal to, and our magnitude or modulus, root 13, our angle symbol here, and 33.7 degrees. Now I'm using degrees because I do prefer to work in degrees, but obviously radians is the SI unit. If you're wanting to then turn this part, the angle, into radians, what you can do is you can take your angle in degrees, so 33.7 degrees by pi over 180, and that will give you your value in radians. Another way we can give in polar form is we can say z is equal to r by e to the I theta. And we are now going to go on the next video and look why that is true.